Bismillahirrahmanirrahim. For inelectronic circuit like this one, we need different electronic components like breadboard, different active and passive electronic components, and power supply. So here is the power supply, which can provide voltage from 0 volt to the maximum 16 volt. So there are two meters. One is voltmeter, which measures the energy of electron, how much energy one column has. It indicates the voltage, the energy of electrons, and ampere shows the flow of electron. Energy of electron, voltage shows, and ampere shows the flow of electron per second. It's the joule per column. One column, how much energy one column has. So it's the power supply, and the product of voltage and current is called power. Electronic power, electric power is the product of current and volt. So the first thing which we need for our electronic component, electronic circuit, is resistor. As its name indicates, it resists oppose the flow of current. By this we can control the rate of flow of current. If a resistor has high below, the current flow will be low. If a resistor is of low below, the current value will be high. Second one is the LDR. It is also a resistor, but its resistivity depends on the amount of light which is falling on it. It is LDR, light dependent resistor. If more light falls on it, the resistance will be low. If less light falls on it, the resistance will be more. And that one is another one is the capacitor. Capacitor is a charge storing device. By it we can store the charge. It stores the electrical energy in the form of electric field. There will be electric field. By the electric field, the force of attraction between negative and positive charge, we can store the electrical energy. It is a voltage maintaining device. By this device we can maintain the voltage. If you put in the circuit, and if then it will get charged. After charging, if in area in the circuit the voltage drops, it provides electric current to maintain the voltage. It is a voltage maintaining device, and it has many applications in electronics. The polarity must be considered in designing the electronic circuit. This side is always connected to the negative terminal, and this side should be connected to the positive one. It is electrolyte capacitor. They are marked. You can see in deep there is a strong or embedded marks inside it, so that there is electrolytes. When we get hot, it may burst, and the hot gases, electrolyte gases, may come from this side. This one is the ceramic capacitor. It is also a capacitor. We can use this only in AC circuit as well as DC circuit. It has no polarity, but the electrolyte capacitor must be used only in DC circuit. It cannot be used in the AC circuit, because the AC current changes polarity, but DC current does not change polarity. Next one is the solenoid coil. The solenoid coil, we can see it is a current maintaining device. When the current passes through it, it makes a magnetic field, store the electrical energy in the form of magnetic field. It opposes the change in the flow of current. If the current increases, it will oppose to decrease the current. If the current decreases, it opposes to decrease the current. It is a current maintaining device, which has many applications, which is used in oscillators and power supplies, in transformers and relays. Next one is the diode. Diode means it has two diodes. It allows the current to flow in one direction and opposed to move in the opposite direction. So it is a, you can see it is an electronic wall, like a water wall, and this is the wall which allows the current to flow in one direction, and provides more resistance in the other direction. Like a resistor provides the direction opposition in both directions, but the diode opposes the flow of current in one direction and allow the current in one direction and oppose in the other direction. The main thing in the electronic circuit is the transistor. Transistor means it transits the flow of current as well as allow the current, transfer and resistor. Transistor plus resistor is equal to transistor, and transfer the electron and resist the electron. It's a very versatile and very important device. It is a very important invention of the 20th century. Before the invention of the transistor, relays were used in the computer. For example, Z1, Z2 and Z3 relays were used for electronic gates, logic gates like AND gate, OR gate, exclusive OR gate and NAND gate. If we can see, it is a current dependent resistor. It has three parts. One is called collector, and that is emitter. The middle one is called base. So by the base current we can control the collector to emitter current. If you can see, it is a current dependent resistor. If the base current is low, collector to emitter resistance will be high. If the base current is high, then collector to emitter current will be low. If the base current is high, collector to emitter current will be high. If the base current is low, then collector to emitter current will be low, or we can say resistor will be high. So it is a current dependent resistor, which resistivity depends on the amount of current flowing into the base. It was discovered by a team of scientists like Jean Bardeen, Brittin and Shockley. In the modern computer, billions of transistors are used. It has many applications. It may be used as a switch, it may be used as an amplifier, and maybe as a function generator or a signal generator. But as a switching effect, it is very, very fast. It can turn on and off about billions times per second. Like our computer clock frequency is due to this transistor, which is called clock speed. It has a very fast switching effect. Next one is the voltage. This one is called rectifier. It consists of 4 diodes have been used in it. It converts the AC current into DC one. The outer portion is for DC one, like this one you can see. The positive side, one side is positive, other side negative. We apply the AC in these two are middle terminals, and we can get the DC from the outer terminals. We provide power DC about 3 to 30 volt AC. We can apply in the middle two terminals. We get the DC from the outer two terminals. Next one is the relay. It is relay. We control the relay by the transistor, and by the relay we can control many electronic devices. Like for example, this solenoid valve can be controlled, and a heater, electric fan, all the electric components, AC components, large devices, appliances of the homes can be controlled by the relay. A relay has 5 pins, as you can see. 2 pins for solenoid power. We have to provide the power to the solenoid or coil inside it. Like there, as you can see here. Yes, 12 volt and 400 ohm resistance. When it passes through the relay, it produces a magnetic field, and this magnetic field attracts the steel strip or the iron strip, and this way first these two pins are connected. When we apply power, then this pin becomes off, and these two pins close to each other and make a circuit, and this we can force from here to there. There are many kinds of relays. For example, this one, the solid state relay. It produces no electric, it produces no sound, and it is a solid state relay. We can use this one in the circuit. For example, from 24 to 380 volt AC can be controlled, and here we apply to DC volt to control the relay, and these two pins are for AC source, attached to the AC source. And this one load should be connected to the two, and power should be applied to this one in this direction, because drag and tracks are used inside it, which will have polarity. And here optocouplers are photo transistor and diode, the LEDs are used for controlling this device. So solid state relays are very fast, but it produces no sound, but it may have high precision, it needs certain precautions to use. Next one is this one is the crystal oscillator. This is the crystal oscillator. What crystal oscillator does for us? A crystal oscillator is used for the clock to generate a clock frequency, for accurate timing of and our clocks. This crystal oscillators are used. On the crystal oscillators there are quarks. The quarks works according to the piezoelectric effect. When we provide the power, it will oscillate with a constant frequency. So it is used for using microcontroller and for our watches, and more other electronic circuit. It is used as oscillator for producing oscillation. Next one is the trimmer potentiometer. It is a variable resistor which will change from 0 to 5 kilo ohm or 10 kilo ohm or 100 kilo ohm. So by turning this one turning the middle dial, we can change the variable, and we can change the resistance from to a given desired value. This one is the voltage regulator. IC7805 IC. It's used for as a voltage regulator. We have to provide power from 5 volt to 30 volt DC, and we can get constant DC of 5 volt. It is push button. It is used in circuit, especially for microcontroller and other small amount of current. We can use it. This is optocoupler. Optocoupler is made from photo transistor and light emitting diode. It provides insulation between two parts of the circuit. Like a relay, we control the current, and by this optocoupler we can also control small amount of current and for insulation to different parts of the circuit. This one is the light emitting diode. Light emitting diode, it emits light when current passes through it, and it dissipates power with less power. Dissipation power is very less, and the amount of light lumens is very high. So nowadays LED is used, and every home appliances, home light bulbs, LED bulbs are used, and screen, it is used in the screens, and it is also used in the signboards, and for decoration we use the LEDs. And next one is the Zener Diode. Zener Diode is also diode, but it we used in the reversed based. It drop the voltage from 3 volt to 15 volt, depends on its rating, its value. So it very little less amount of current can pass through it. So we need a resistor in series. We need it in series in order to use it in this way. Direct current cannot be passed through it. We need it such a way. We have to connect a resistor in series to limit the current passed through the Zener diode. It is IC circuit, IC base, we can say IC base, IC circuit. First, we should for designing or making any circuit. This is first soldered in the board, so that the high temperature may not damage our IC. So we should use in this way in the board. But then we have to solder it. After that we can put IC, insert IC in it, and when the IC becomes or when the IC stops working or burn the IC, then we can change from this place. This is the GSM module. GSM is a device which is used for communication for long input output for our circuits. Its application needs to operate it needs the microcontroller. Simply we cannot use it. In the simple circuit we can't use it. It needs a microcontroller and programming C language it needs to operate it. Next one is selector. It has different input outputs, and it is 3 state 1, 2, 3 state 1, 2, 3, 4 state it is. So it's a simple selector. You can use the switch. And we know the breadboard. First we have to design our circuit on the page. After designing on the page, we have to check this circuit inside in the wire board. Then in the breadboard, this is a breadboard. For example, these lines are connected in vertically, horizontally, and these lines are connected in vertically. We have to provide positive, negative power here, and then we can insert different electronic components like a diode, like a LED, a transistor, and optocoupler, LDR, and we can design easily on the breadboard. After successful experiment of the circuit board, then we have to make the permanent circuits by soldering in the wire board. This is called wire board. Then we have to make the circuit on the wire board permanently by using the soldering wires and solder. Now it is the solder. It is about 30 watt. It is used for making a wire board circuit, and its stand